All right, so I'll be demonstrating how we have been using a custom resolver to integrate ENS and zk money. Now, the first step for that would be to deploy our custom resolver, which I have already done on the mainnet. So here's the address for that particular custom resolver that we have deployed, and we'll be using this to demonstrate the entire process of how do we integrate the ENS and the zk money. So first off, this is the main network, and with my current address, I've already registered my ENS name, that's chagro.eth. And if as you can see, like we already have a resolver, which is the default resolver, already set in. But we need to first change this to the custom resolver that we have deployed. But before doing that, I also want to show the interface of how the zk money looks like. So with the same account that I used for registering my ENS name, I have also registered on zk money, and this is the screen after the login part. I have already shielded like a few ETH here, but that's not of that much of importance. But I'll show you how this interface will update once I send some ETH using the custom resolver. So let's copy the contract of the contract address of the custom resolver and update the resolvers and set the resolver here on ENS. So here we go. That's the contract address of the custom resolver, and we'll be setting it anew. We'll confirm this, and this is all happening on the mainnet, by the way. Confirm. Let's wait for the transaction to be confirmed, and after that we are already good to go. Like that's how the interfaces would look like. And the cool part about this solution is that the existing interfaces from ENS and zk money can be used as it is. Anyone who already has an ENS name register can simply update their resolver to point to this new resolver and start using this resolver. So yeah, we have now updated it to the new resolver, and let's see, like here there is currently no change, but let's send some ETH to this ENS name, and this will be done by a script that I've already written, because as of now there is no in-wallet support that is required, that is implemented. The reason for using the script instead of like a normal transaction from MetaMask is because we won't be sending it directly as a simple transaction, but this will be a contract call. And in that contract call is basically done to this custom resolver that we have deployed. Basically what it does is it takes the ETH which is coming its way and fetches the actual address of the ENS name and uses it to send it to the Aztec Connect contract. So this is the main contract of Aztec Connect, and here the method deposit pending fund is called, and that's it. Like that's how the script works in the deployed contract. And I'm just going to run the script now, which will initiate a transaction from a random another address which is not associated to zk money or this ENS name, and we'll see later on that the money is being showed up and how the money is being showed up in zk money. All right. So yeah, this is the latest transaction, where we have set the resolver to the new one. And let me just run the script. Let's wait for this to run. Cool. Now it basically says that the ETH has been set. See how the UI looks like now. This will depend on how fast the Falafel processes this pending funds. So Falafel is basically like a server, which is running to track all the events on the events emitted from Aztec Connect, and it would show uh, anything that is being pending on this particular UI. So if we go here, well, with the Shield fund, you can see that we have 0.00 pending on this contract. This will be used first. What this means is basically like the amount of money that we have sent using that particular script is now being shown automatically here. I mean, automatically in the sense that the falafel has already watched the event, the emitted event, and is now showing that, yeah, it's available. So we can claim it on L2. So let's put the amount here. This, even though the balance shows 0.006, this won't be used as it says here that the pending app will be used first. And let's just do the default one so that it's cheaper. And let's go and do this. And yeah, so you might have this question like, why do this receiver who received also needs to now pay for it? So because now what happens is like with this particular transaction that we are trying to do, we are submitting a proof that we are actually the owner of the pending funds. To do that, we will need to spend another transaction. But the cool thing is like the receiver need not do for every transaction or every ETH that it has received, that they have received. So they can wait for, let's say, however long, like a week, a month, whatever their preference is, and then submit just one transaction for by accumulating all the ETH that they have received on L1 as an event, and then convert it to the ZK ETH that they can use on Aztec. Let's wait and see how this works. But yeah, that's it. And just sign once more, approving, and done. So that's basically how the entire transaction has worked. And we have the shielded amount available for us to use again. Although we cannot directly use, like the available still shows 0.001 because the block has not yet been confirmed on the Aztec side. So if you see here, it's like one green tick is still missing, but once it does, then it will be confirmed. So that's it. That's all we have.